Hello and welcome to the last episode of the Oxford MAT Livestream for 2022. Great to have you with us. My name's James. I'm the admissions coordinator for maths at Oxford. We've been doing a series of live streams about math problems, but today is a special bonus episode. We're going to talk about some interview questions instead, and I'm going to talk a little bit about how interviews work at Oxford. Gosh, that was quite a scripted entry, wasn't it? I don't normally have a script. Hi everyone in chat, how's it going? I've been talking to people in chat just before we went live, and it seems like some people are still waiting for an email from Oxford colleges to find out if they've been shortlisted or not. Don't panic if that's you. Some colleges are doing the subjects in different orders to other subjects, and they've got to do like the English emails and the physics emails, and they're doing them in different orders. So some colleges haven't done the math emails yet. I wish they had, because I want to talk about interviews, and lots of people don't know if they have interviews or not. So apparently Magdalene, we're doing like a name and shame in chat, I guess. Sort of. Kai says no. Anonymous says Magdalene, good or bad? Not yet. Doesn't matter. I have put a jacket on and had a haircut. It's not for anything in particular. Just I've discovered that if you put a jacket on, people think that you've tried. So I keep a jacket in my office now, and I put the jacket on. It's like I tried. It's like a cheat code. Jack, so some people have got interviews, some people are here even though they've found out they don't have Oxford interviews. Maybe they have interviews for other universities, or maybe they have other interviews in life coming up, or maybe they just want to see some maths problems, and we will get there. Eric is trying to get the thumbs ups, waiting for St Caz, waiting for Merton maybe. Someone's really glad that Cambridge, one of the other universities out there, doesn't use my test. Fair enough. Okay, right, okay, I think out of people in chat, Jack's got an interview. So I can do this just talking to Jack, but I think I can talk to everyone. Yeah, well done, Jack. Well done, Jack. And maybe some anonymous people, and maybe some people not in chat as well. How are we doing for YouTube? Let me just quite quickly check. YouTube's giving me not an error message, it's giving me a suggestion. The stream rate is too high. This is coming at you in extraordinarily high quality, so that's good. Is this going to be useful for computer science interview applicants? I think yes, especially if you ask questions. Quite often I'm going to say maths because I'm a mathematician and I think a lot about maths submissions, but most of this is going to apply to computer science. The example interview questions that I've got were all maths interview questions. Computer science slightly different, and we can talk about that when we get there. Difficult sometimes because I use different words than Americans use. Americans, you are welcome to interrupt us during interviews and ask us for clarification on what words mean, and everyone else, I suppose, as well. That's not just a special US offer. Anyone else? Oh my goodness, someone's got an email from their second college but not from their first college. I hate it when that happens because it's very confusing. Don't overthink it, let's just wait for the emails to come out. And have I got shortlisting bands? No, okay. Is this going to be useful for PAT? So the format of interviews is very similar for lots of STEM subjects, lots of science, technology, engineering, math courses at Oxford. So I think the physics interviews work in a similar way. Slightly different content, of course, because they're looking for people to do a physics degree rather than looking for people to do a maths degree. Nicholas, I think some people have heard back from Imperial, or was it everyone got an email? Was it everyone got an email saying your application is being considered or something? Everyone for Oxford, people should get emails by Monday, I think, because we try to give people a week's notice. And somebody's mail merge, I think it's a mail merge from St Hugh's, went out at 9 PM. So let's give all my colleagues a bit of a chance. How do you know your second college? Right, let's not think about second colleges too much. Thank you for the live. I enjoyed 3 minutes. There we go. That counts as one viewer. That counts as one viewer on the YouTube stats. You can stay for 3 minutes and you still count as a view. Doesn't matter how much more live stream I do. That's a view. Good times. Right. Okay. How else are we doing? This is someone who told me just before they went live. They said that their teacher said that they could watch the live stream, but only 3 minutes of it. And they haven't seen any maths at all. But maybe they asked that US question because I think they're in America. So maybe they asked a question. Yeah, that's what we want. Right, let's do a poll. Sometimes when we're here we do polls about how was your day. I'm kind of interested in this one. the maths test was now about a month ago, so maybe people aren't cross about that anymore. Maybe you are cross about that. Sort of get where you're coming from if you're cross about the maths test. But maybe people are sad about being not invited to interview, or sad about being invited to interview, or there was a hypothesis in chat I saw that this would be a bit bimodal. I'm going to ask a couple of questions behind here. Uni's got an interview. Congratulations, Uni. Why don't Oxford just interview more people? We like to interview people multiple times, and that is a policy where you could go. We could interview people less rigorously, but we're a bit worried about people being very nervous during their first interview. Imperial have been, Imperial online entrance test. Hadn't heard of anybody getting anything beyond that. Right, Imperial, bit of spamming and then nothing else. Christchurch 9 AM. There you go. And the poll is as predicted by. Oh, actually, is that bimodal? Does it count as trimodal if the 1 stars? People are voting for odd numbers today. Their day so far has been going at about a 3.7, but that hides the fact that odd numbers 1, 3 and 5 there, much more popular. Carl Frederick Gauss would like to vote 0. Minimum number of interviews, if you're interviewed, is 1. Almost everyone gets interviewed by a second college. That's almost everyone. I think we hit 95%, 99% in maths. That's a maths specific statistic. Of giving people a second college interview, we really like to do that. And lots of colleges do more than 1 interview, so often end up for about 3. There was a question in here somewhere. Pat, no, goodness, confused. There's the second college. I'm keeping up with chat a little bit as well, and also waiting to see if 4 can win and make this more of a unimodal distribution. This isn't really a statistics stream. Do colleges send out emails over the weekend? Somebody's asked. I'd have guessed no, but I'd also have guessed no to do colleges send out emails at 9 PM. So I'd be wrong about that. So let's never say never. Git, right. Okay. 3 is just overtaken, which is, the middle, right? Okay. Maths and philosophy might do separate interviews, might join them together. Actually, it's more usual, I think, what you might expect is to have separate maths interview, separate philosophy interview. Occasionally merged together, but seems like it's easier. That's a scheduling sort of thing. Okay. Do we ever make offers without giving people interviews? Not really. That's not a thing. We kind of shortlist down to our interview group, and then we make offers from within that, shortlisting lots of people. And the MAT does still matter. Are we able to do an interview at home? Please contact the college that's invited you to interview. I think that is a possibility for Oxford this year. More information about how to actually do the logistics of it. We want everyone to do their best in interviews, so we're working with people. Once we've shortlisted, we've got this group of people we can work with. Further maths, that was a question earlier. Is further maths fair game? Which I think I put under a kind of what category. What are interviews? What happens in interviews? And I think if you've learnt it in school, then if you've learnt it in school or equivalent, then it's sort of fair game. But if you know it, then you know it. And the more you know, well, it's just good, isn't it? Knowing maths is always good. Are we going to ask you questions from the Further Maths textbook? Probably not, because questions for the Further Maths textbook are mostly just checking that you've learnt further maths, and that's not an interesting check for us to check has this person learnt this particular topic yet. This is sort of tells us something about the sequencing that your school teaches maths in, but doesn't tell us much about how you solve problems. We want you to solve problems. Latest we can get invited to interview. I would say that all these emails should be going out by about Monday next week. Friday, Saturday, Sunday, Monday. That's like 4 days. Let's not panic. Did I mention that we're sending out tablet or stylus? I think I mentioned that I was not allowed to say that. I think I was very careful. Contact the college that shortlisted you. Let's work it out. The Oxford system, by the way, for second colleges, because they've come up because somebody asked about second colleges, and here they are again. For Oxford interviews, for maths at least, everyone gets assigned a second college at random if they've been shortlisted for interview. That means that there's a second college who's been assigned to this applicant. so that if there's no space at the first college for this person, there's a second college who will see them as well. After that, there's a big meeting where any college can make an offer to any shortlisted candidate. So in some sense, there's a second college, and then sort of everyone else is 3rd, 4th, 5th, 6th, 7th, 8th, down to 29th or something. Good, right, okay. Trinity, brilliant, right, good, okay. Just got rejected, but thank you. Okay, right. Sorry about that. Sorry, I shouldn't have laughed when you said that, but it was like double. The comma splits it so much. Right, okay. I thought I'd start by doing information about interviews because we're getting some questions in chat, and I've got a framework for answering questions. We're going to try and split these out into the why, what, where, when, who, and how of doing Oxford maths interviews. If you're the person who asked about PAT, then you can imagine it says physics in here and apply common sense to change some of the maths words to physics words. If you asked about maths computer science, then you should imagine being asked computer sciencey stuff at some point. Right, okay. And good, right, again. People are talking about tablets now. I have a tablet. I have a very, very cheap tablet that I got during the pandemic years ago, and amazingly, it hasn't broken yet. Okay. Am I interviewing? Yes, I am interviewing for Christchurch again this year. People watching the video in the future, who knows who's employing me next year? Oxford applicants automatically, username Pi, Oxford applicants automatically get their MAT score in January. Check the MAT page on the Oxford Maths website down there somewhere. Oxford Maths website MAT page for more details about how you can get your MAT score, everyone. Right. I thought this was good. Eric's like, oh no, English. I thought this was a structure. Why? So we are oversubscribed. We have, oh my goodness, come on. There we go. That's what letters look like. This is an English test. We have a lot of applicants, which is a good position for us to be in. It's really nice meeting lots of people who are really interested in mathematics. We want you to give you a chance to solve some maths problems. So one way to think about this is a sort of opportunity to turn up, solve some problems, be given some problems, solve some problems, and then be given some more problems, try and solve those, and to talk about what you're stuck on when you're stuck. We want to see what happens when you get stuck. So let's make this grammatical. Solve, but also not solve some problems, which I've put in to be a little bit provocative. There will probably be a point in a maths interview where you can't solve something. So something that you can't do, which might be a terrifying feeling because you're probably used to being able to do maths problems. Although I say that thinking about how people reacted to the maths submissions test. Maybe that was the first time that we saw math questions that were impossibly difficult. At some point in interviews, all the people I've ever interviewed get stuck at some point and need a bit of help. And that's good because then we can give you some help and we can get you unstuck. We can help you have ideas. It's a bit like how when you're on a university course, you're going to meet lots of new things and you're going to learn lots of new things, and you're not going to understand all of it straight away. You're going to need to do a bit of work, have a little bit of help, and get unstuck with your understanding. We might try and simulate that during an interview, but I'm getting into what, so I'm going to stick on why just a little bit more. A couple of questions from chat. Kai, you get sent the total score in the automatic email. I think that's how the mail merge works. Oh, it's a mail merge behind the scenes. Anonymous person wants to know if we're doing the picture from the thumbnail, and yes, it's not clickbait. At some point we will talk about that expression that's in the thumbnail of the video. Sorry if you clicked on it and I've just been talking for 15 minutes. Question specific marks and feedback from the MAT. I think technically you can do, it's sort of personal data, so you can do some sort of personal data thing to try and get access to your personal data. It's not in the automatic email, that's what I'm saying. Okay, Ollie, lots of people are waiting for a reply from their college. I had hoped that they'd send out all the emails before I had to do this live stream talking about interviews, but here we are. Helping. So there's a bit of helping involved in this, there's a bit of learning involved in this. There's a bit of getting unstuck. Unstuck's not quite a word, is it? I'll put a hyphen in it so that it looks like a getting unstuck. And some quote marks around it. There we go. Good. Okay. These are all reasons also why we do the maths submissions test. We do this maths test that we've built a whole live stream around because we've got lots of people and we want to give you a chance to solve some maths problems. So we've sort of already done one pass of this. The difference with interviews is that we're there to help. Okay. Do Oxford interviews ever have? Right, so let's move on to what, because I can see a what question has just come in. Do interviews have why you're applying for this course or university or college questions? Short answer, no. We know why you're applying for this course because this course is great. You've already given us a personal statement. So we've already seen you write 4,000 characters about why you want to do the course. So we sort of already know. Why this university? I mean, this university in my case is Oxford. We know why you've applied to Oxford. Oxford's great. Which college? We're actually not able to ask why did you choose this college because we don't know that you chose this college. You might have made an open application. We can't assume. So that would be a bad question because it would be a bit like asking why do you have green hair if you don't have green hair. It doesn't make any sense. Good, right. Score I got in PAT. I have no idea. Oh no, I do know this. PAT scores have some sort of automatic process. Contact the physics department. Don't contact the physics department, actually. I know the answer to this. Wait, hang on. Everyone's going to email them. I can save them some emails. They're sending out automatic PAT scores. I think they're not sending PAT scores to people who are made offers for Oxford. They've removed those people from the mail merge. So I think they're sending out PAT scores to people who are unsuccessful in some sense. If you're not an Oxford applicant, please check the MAT page for how you can get your MAT result out of Imperial or Warwick. If you're not applying to Oxford, then hey, thanks for clicking on the Oxford website. Welcome to Oxford Mathematics Plus. You're probably applying to one of those other universities and you can talk to them about their feedback processes. They're using it as a part of their admissions process. Anyway, I've got off topic. Gone off topic. It's the total score that gets sent out in an automatic email. We put it at the bottom as well. So bottom of the email says, if you don't want to know your MAT score, please delete this email. And we put lots of new lines and we put full stops in the new lines so that your email program doesn't truncate the white space. We put lots of dots in so you have to scroll down to see your MAT score. And we send all of those out for MAT. Good, right, okay, if you don't want it, it'll be obvious what it is, delete the email without reading it. Good, right, okay, what for interviews? Interviews. That's what the live stream is today. Oxford interview live stream. So for a maths interview, we're going to ask maths questions. Which is sort of maybe the stupidest answer I could give you. It's almost insulting. But what I mean here is I don't ask questions about people's personal statements. Some of my colleagues do to try and make people feel comfortable. I don't ask about people's personal statements as a personal thing. I suppose I could if I wanted to, but I've never really felt like it. I've got access to the personal statements, I could ask questions about them, but usually I've got a maths question in mind that I want to try out with this human in front of me. I would like to do some maths questions. You would probably not be asked if you've read any books, because you might have already told us about some books on your personal statement. And I also don't like asking questions that you might have prepared an answer to, if that makes sense. So not so much prepared statements. Which is maybe good news for you. It means that you already wrote your personal statement. You don't need to prepare another statement to get ready to do that during your interview. Please relax, we're going to do math stuff instead. That's the kind of first approximation to how these things go. If somebody asks you a question that is not strictly speaking a maths question, they are probably just trying to make you have a nicer, welcome you in. They might be checking who you are. They might be checking that you're in the right place at the right time, and then they're going to ask you a maths question in the moment, I promise. A mock interview, the questions are hard. Yeah, it is an opportunity for us to ask hard maths questions. Let's put this in somewhere over here. Hard, or I'm going to put hard, but hard's not quite describing the questions right. What I like to do is questions that have a sort of ramp, so that I give you some maths to start off with that hopefully you can get started with. You can get in and do some maths. And if you can't, then it's probably because I described the question badly. But hey, I'm here. I can help describe the question again in a different way. But then once you've done that, I want to ask something else that's maybe similar to see, can I give you the harder version of this question? Can I make the question harder again? Have you understood what was happening in those first two parts of this, to understand what to do in this next part? It's a bit like the way some math questions ramp up in difficulty, except in the math question you can read ahead, and in the interview I'm holding it in my head until we're ready to move on to the next part. So it's like having a bit of a ramp happening in there. Eric says, phew, it's maths, not English. And I remember Eric was the one who was disappointed by my who, what, how, where, when. Perelman wants to know why they've got 2 interviews. Some colleges schedule 2 interviews. Some colleges schedule 1 interview. The number of them varies a little bit from college to college. It's with 2 interviews, it's usually because they want to interview with 2 different groups of interviewers. Sometimes they just want to interview with 1 set. Back when I applied to university, I got 1 interview total. That was it. So, yeah. Don't want to talk about myself either. And in the nicest possible way, I don't want to use some of the interview time for you talking about yourself. I'm not going to talk about myself. Oh yeah, you should definitely not look up me. You're definitely not going to not about your interviewers. Which sounds very conceited when I say it like that, but I do sometimes think that people are advised to look up their interviewers online to find out what research interests they have. I personally think that's a waste of time, because if you look up me, you'll find out that my research interests are fluid dynamics, Reynolds number 1, and complex maps. I'm not going to ask about that in an interview because I can't think of a good interview question that's anything to do with that. So all my interview questions in the past have been nothing about my research, nothing about what's on my website. If it was, it would feel a bit like a prepared statement, to be honest. You would look it up, you would say, this person likes fluid dynamics, they're going to ask me about fluids. I will prepare a statement explaining that I like fluids too. And do most people get 4 interviews? Some people get 4 interviews. Don't read anything into this. If other people want to interview you, it's because they want to do maths with you. That is, I think you should always see that as a good thing. There are multiple reasons behind the scenes why a college might want to organise more interviews. They might be trying to calibrate their interviewing pairs. They might be trying to show you more maths questions. They might be trying to compare against a different college. Or we like to do interviews once we've got people going for interviews. Good. Okay. Is 3 interviews a bad thing? No, it's 3 bits of maths. Everyone likes maths. I'm not sure I've done very well here at describing what they are. So normally they're about 25 minutes long. Let's go 20 to 30 minutes, let's say, with 2 interviewers, 1 interviewee, 2 of us, 1 of you, talking about maths problems. Ramped. I haven't spelt that very well, have I? The E doesn't look like an E, and the A doesn't look like an A. Interview decisions should go at the same time for everyone. In the mail merges that colleges are doing to send out interview decisions, they're going subject by subject, I think, rather than country by country. As if you might like to check spam and junk folders, or it might just be the case that the college hasn't sent out their maths or computer science emails yet. Okay, maths questions. Good. A couple of questions in chat before I move on to, gosh, what's my next one? Where? Right, okay. Someone's got rejected from Keeble. I wish Keeble weren't sending out their emails during the live stream. That's not very helpful, Keeble. Sorry. You're welcome to hang around for the rest of the live stream if you like. We'll do some maths. Why have I been in a 40-minute slot if they're only about 25 minutes? Usually about. Different colleges are going to do different things. Sometimes I've seen joint honours, maybe? Joint honours. Sometimes I've seen people schedule a bigger chunk of time because they want to ask about multiple things. Maybe they're just on a 40-minute time slot because they're worried about starting late or overrunning or having technical problems. Maybe. don't read anything into it. If your interview is 20 minutes long or 15 minutes long or something, that's not a bad sign. Good, right, I'm just trying to give you an idea about what's going on. For maths and so on, we're going to be doing these online. That's for Oxford in 2022. Oxford, I've got to date the video. If you're watching this in the distant future, let us know in the comments. No, don't. If you're watching this in the distant future, please check the interview website. I should probably give you the interview website at some point. Cora's got mixed info. Do you only hear about third or second interviews after your first one, or are they going out now? Cora, I think you might have got mixed information from me. I thought they went out afterwards. I've just heard from someone in chat that they've got a second college interview notification before their first college. I think it's all going out at the moment. Why have you? Hang on, you've got a second college notification. Something. I need to look behind the scenes at this sort of thing. I didn't think we'd scheduled them yet. Maybe somebody started scheduling them. That's very keen, whoever's sent them out. I'm surprised that the second college ones might have gone out yet, because... Anyway, right, behind the scenes systems. James is going to send an email after this. How many completely different questions do interviewers ask on average? One big one. So, normally, so that's a what question, isn't it? This is good, I like the questions, thank you. Sometimes these videos, if I record a video about interviews, sometimes it's completely useless because I forget to say important things. Different questions. So I would say usually about 2 questions, whatever 2 means. So my question's got lots of parts. You might not be able to identify what one part is, but a normal format, not everybody does this, but a normal format will be to have 2 interviewers and to take turns asking one biggish sort of question with different parts in it. Do I use an iPad for Miro? You can if you have one. If you have a tablet or something, let's go for a where. For maths at Oxford, I can't remember what physics are doing. I think it's the same as this. We're using a website called Miro. Hey, shout out to Miro. Which I've been practicing with for the MAT Livestream. It's an online whiteboard. It's free to join and set up a small number of boards, I think, and it's free to join somebody else's boards, which is what we're doing. Miro lets you write. It's collaborative. I've had, I don't know if you've noticed this, but right next to my face there's been like a share button for the entire show over the last couple of months, and we considered doing this where I just sort of share the link with 100 people in chat and see what happens to do the whole MAT live stream, but I think we realised quite quickly that would be a bit of a mess. But for the interview, it's not a mess. We're going to share a board like this one. I'm using some sort of graphics tablet. If you've got some sort of tablet, they're quite good at writing on boards. If you have nothing that can interact with an online whiteboard, then please contact the college that shortlisted you, let them know, and we'll see what can be done. Confirmation of shortlisting, but no interviews confirmed. Well, congratulations on being shortlisted. That means your college is doing 2 rounds of emails. They wanted to get the first one out to let you know as soon as possible, but they haven't finished scheduling when the times are. Don't worry about it. We're spending, gosh, there are about, a conservative estimate is about 100 maths tutors, and all of the college offices are spending a lot of this week doing all the timetabling for all of the people we're interviewing. Oh, yeah, Kai feels sad. Sorry, Kai. Yeah, okay. Yeah, people are getting emails out of order, but oh well. Okay, let's do when. So they're mostly in 2 weeks' time. I've forgotten how the date works. What is it? I should definitely have checked this number before going live. So mostly 12th of December to 14th of December. That is, let's put the disclaimers on. 2022, Oxford, and maths. Although CS are doing the same dates, and I think physics are doing the same dates as well. Some overseas candidates maybe have interviews on the 9th of December. We're doing some on the Friday before as well. Oh look! Some crabs have been given an interview. That's the crab raid, isn't it? Is this Miro board going to be shared? No, I decided not to share this one because I didn't like the idea of 100 people adding crabs to the board or whatever. Okay, we're trying to do them during the daytime. We know about time zones. We're trying, part of the complication of scheduling all of our interviews is that we're trying to accommodate time zones. If you're scheduled an interview for a time that makes no sense, it's because we've got confused about time zones and we're sorry. Obviously, just let us, please just, you can say. There was one case, I'm not supposed to talk about particular cases, but there was one case where I thought a candidate was in New Zealand. They were not in New Zealand. They were in the eastern United States. Those have very different time zones. Yeah, it was a thing. Really sorry to that candidate who just let us know and rescheduled things. Is it possible to request further feedback even if you didn't get an interview? Yes, feedback process is at the end. In January, end of our process, in January you can request feedback, which if you were deselected after the maths admissions test, there's probably going to be talking about maths and maybe talking about your application, your UCAS application too, because that's what we had at that point. Is it possible to use a tablet for Miro and a laptop for Teams at the same time? Yes, if you've got both. You can join the Miro board. You can join the board on one device or a phone or something, and you can join the Teams call on a laptop or something else. Sometimes I've seen people join with a phone for the webcam. Anyway, who I've sort of already covered. One of you. I have to say that because some places out there, I think not for university admissions, but some places have started doing these panel interviews where they have multiple people. One of you, approximately two of us, where us means maybe tutors or graduate students who have done some training, or postgraduate students, or mathematicians, or other people associated with Oxford teaching and learning. We're going to ask some maths questions. Good. Okay. I'm losing faith in my who, what, why, where, when breakdown. But I think I'm getting further around the circle. We're down to how. This is the last one. Okay. We split it into 6 mini sections, and we should do some maths questions in a second, right? So this is like, how do you prepare? How do you do this? And the good news is you already prepared. You already prepared in 2 different ways. One, you've been going to maths class or lessons or whatever you do to learn mathematics. So you have been learning maths and practicing it and getting good at maths. And also, if you've been watching the show, then you've been trying some hard maths questions. You've been getting stuck on things. You've been doing math questions or whatever, and you've been trying to apply the maths that you know in different ways. Those are very similar skills to what we're doing during interview. So good news, you already prepared. You might like to try talking to someone. Some schools organise mock interviews. If you can have a mock interview, then that's great. If not, I recommend talking to someone about a maths problem. Maybe have a go at a math problem and then explain it to someone in your class what you did for the math problem. I'm recommending this because actually talking about the maths that you're doing is quite a subtle skill that you might want to practice it so that you're more relaxed or confident when you're later talking about other maths problems. Communication is important. I love talking, look at me. How do you prevent being stuck under pressure? You will be stuck. And I'm afraid it's likely that you'll experience this as pressure. Ask for help. We're there to help. Say, I don't know. It's much better if you say something like, I don't know, or sorry, could you repeat that, or what does that mean, or I'm going to try an example with small numbers. It's much better if you say something rather than saying nothing. If you're saying nothing, if in doubt, ask them to repeat what they just said. If nobody said anything for a while, the interviewer is going to say something else. We are encouraged to help you out, and if you don't say anything, to help prompt you for what's going on. Carl Frederick Gauss has to suppress talking about what I'm doing in exams. I sometimes think it's slightly artificial, maybe, to shout out the names of your moves as you're doing them, but there is quite a big difference between just sort of doing the maths versus if you say I'm going to integrate by parts now, or whatever you're going to do. I'm going to try integrating by parts. Then the interview, I can relax a bit. I'm stressed too. I can relax a bit and say, okay, yeah, carry on, off you go. Or maybe I can say, oh, I've tried integrating it by parts and it's much harder than I thought. In fact, I think there's a quicker way to do this integral. And then you can look at it again and say, yeah, polynomials, or something like that. That's a discussion we could have during an interview. I got a rejection. Oh, I'm really sorry. Don't take it personally. You are still great at mathematics. You are still enthusiastic about mathematics. I think you're still going to do mathematics at university if that's what you're applying for, because you've got 4 other university applications. And I think you're going to do well at it, and I think you're going to enjoy it, and that's more important. This isn't the end of the road in terms of you doing loads of maths, if that's what you want. Don't take it personally. It's not you, it's us. We've got way too many applicants for the number of rooms and chairs. Right, consider small numbers. That's a good secret move. And then we'll say, oh yeah, okay. I'm not really joking on that one. There's an interview question I've done before where what I really want is for the candidate to say something clever about prime numbers. And my bar for saying something clever is very low. The thing that I would quite like them to say sometimes is, there is such a thing as a prime number. For example, 3 is prime. Sometimes that's what we need. We need the idea that there are any prime numbers at all. The thing I'm working on as interviewer skill is to try and get people to say things that they think are stupid, because they're trying to be. They want to say really clever things. Everyone wants to say clever things. Saying clever things is great. But sometimes you need to say something that's not particularly interesting, but is true. And 3 is prime is maybe an example of a true fact that I wish people were more happy to say. Oxford interviews, we normally get 25 minutes. Feels longer, sometimes feels faster. Are there any offer holidays? Sometimes. I don't think the maths department organises one for everyone, but some colleges do things like that. Prime numbers have 2 factors, themselves and 1. When do we send the URL? In advance, I think. Yeah, I think we send them in advance. College admissions offices, very organised. Sort out all the links in advance. Good. Okay. How many people got an interview? Oh gosh, good question. I think we've shortlisted about 3 people per place. But you should not think about that. It's not random. It's not a percentage chance. It's a whole load of people who we're going to talk about maths problems with, and maybe you're one of them. Good. Okay. Will computer science interviews often have pure maths questions in them, or will they always be computer sciencey? Disclaimer: I've never been to a computer science interview, so I don't know. But I think that they might use more maths than you're expecting. That's my kind of firmly held belief, that practicing a bit of maths, being fluent with maths, might be a good idea. My main advice, I think, is to practice the maths that you consider easy, because there's loads of this stuff that you consider really easy, and you want to demonstrate that it's easy to you. There's sort of nothing more frustrating than having a good idea but then tripping over the details and getting flustered because you're making small mistakes. You'll feel much more confident if you're happy with some stuff that you've labelled, like GCSE maths or something, I don't know, or quadratic equations, they're your thing. And you're really happy with just doing quadratic equations, so that you know you're not going to make mistakes with quadratic equations. You're going to go through and do quadratic equations. Being confident with that, I mean, it's helpful for getting through the interview question, but also I think it's helpful with confidence and not getting stressed. People are now ragging on me for mistakes I have made in the past. What if I say 39 is prime? It's a reference to my firmly held belief as a child that 39 was prime, and this, for simplifying powers. And Raphael has helpfully linked to some past CS questions. I'm going to click that, I think, after the stream. Oh, it's from Varun. Hey, I know Varun. Varun's published interview questions. Maybe I should have a look. Thank you, Raphael. I had no idea. I'm having a look now. It's not very professional to do this now. Oh, it's a blog. I should have guessed that from the word blog in the link. Right, cool. I'm not reading all of Varun's blog right now. Good. Okay. Yes. Okay. Yeah, senior maths challenge, but I've described that as being a child. 39. And the story changes slightly every time. Have we increased the number of places? The number of places has not kept up with the number of applicants. I think maths and computer science is changing in some sense. I think we gained a tutor recently for maths and computer science. I think there's now a college that offers computer science that didn't before. I think. I have a table for this somewhere. Gosh, I think Pembroke is doing exciting things. Yeah. Videos of Aaron as well. Good. James, when will Oxford give out the exact date of the interview to us? I don't want to make promises for all my colleagues in administration who are sending out all the emails. I thought we were planning to give 1 week's notice. So I thought we were planning to give you notice, i.e. I guess by next Monday, if we're interviewing you the Monday after that. But let's not stress about it, because if it takes longer than that, it's probably just because some admin is happening quite slowly. Sorry. Right. What if I have to solve an integral numerically? That doesn't sound like a very fun interview question. You should probably ask, are you asking me to implement the trapezium rule? And then you say trapezium rule and we go, yeah, the trapezium rule. Let's not actually do it though. What a weird, that would be a very, I don't know. I don't think I'd enjoy doing that interview question. Being nervous, I'm worried I might freeze. So I was scared about this as well, and I only have one interview, so if I froze then that was the interview. It's going to be maths questions. There will be 2 people you haven't met before, but also some maths. So that's like 3 different things. I don't have good strategies for making you not scared of the 2 humans. You could look them up online if you want to try and find pictures of them or something. But I think my strategy is that the 3rd thing in the room, other than the 2 humans, the bit of maths that they've shown you, if you find that in any sense a kind of rock that you can look at, maths is not that different from maths that you know. Okay, right, should we do some questions? Let's do some questions. We're going to have a vote. I've picked out 4. I've tried to avoid ones that I did last year. I did talk about one of these last year. If you saw the show last year, then gosh, you've been very patient waiting for me to get to the point. We're going to do a little bit of voting as well. We've got 4. These questions that I've either used or have been used on me, or when did the Hill one? Did I use the Hill question? I'm not sure. I've used all of these. We'll see. People have been very polite and voting for the one in the thumbnail, so that this is not clickbait. We do the thumbnail question. Silly arithmetic errors are fine, by the way. If anything, it's better than in the maths, right? Or in an A-level test where you kind of have to lose a mark if you make a mistake, whereas here we can just help you fix the mistake. And we can see that it's a small arithmetic mistake, and maybe even agree with you and say, oh look, I think that square root of 2 should just be 2, and this is just 3 to the power of 1,000. And they go, oh yeah, 3 to the 1,000, yeah, brilliant. And that's unlikely to have been the point of what was going on. E to the x, that was the joke I did last year. Is that a reference to a joke I did last year? Hill, literally because it's just called Hill. Are the interview questions tech-free? I think I'd say non-calculator, unless you're encouraged to bring a calculator or use a calculator. Not that sort of question, really, I suppose. I can sort of see how. The thing is, this one, your calculator can't work out this number. We're going to talk about this question in a second, I think. Sorry for shaking the screen there. Yep, I think I'm going to give it a second, but it is winning. No, it's more than half, which is exciting, because it means that there's an actual majority of people who want to do a thing, which is very, very rare. You've got a 4-option poll. Right, cool, I'm stopping it there before it gets out of hand. Good, okay. We're going to talk about Surds. So here's the question. I start by writing something like this down. And at first, to try and get people comfortable with this, I asked them Can you tell me anything about this number? Here's a number, 1 plus root 2 to the power of 1000. Can you tell me anything about it? Chat, there's quite a few of you here. You're now being interviewed, I guess, all as a team. Anonymous person, that looks important. I'm autistic and have problems with auditory processing, but I haven't included in my application. I would encourage you to disclose it to the college that's interviewing you so that they know to take it into consideration and, if necessary, repeat things and to just maybe talk slower if that helps. If you don't disclose it, then they won't be able to do things like that. And it sounds like you might be entitled to that sort of reasonable adjustment. Okay, good. Behind the scenes. Oh no, we're not behind the poll anymore. It's 1 plus square root 2 squared to the power of 500. And if you wrote that, I might get you to, or if you said that, then I might get you to expand out the thing inside, which feels like progress because now the power is only 500. It's a big number. Yes, it is a number. I love this. The bar is very low. Well done. It's a big number. That is correct. I might ask you in an interview, how do you know it's a big number? And then you've probably got something to say about how you know it's a big number. And this is fun because in a very short period of time, you've said something and also done and explained that. In a maths question, I have to give you like a couple of marks, and it takes a whole line. But here, it's a big number. Why? And you can tell me why, and then we're good. We move on. Right, cool. Can I participate? Yeah, sure. Root 2 is irrational. This thing is rational. It's too big to store on your computer, right? Okay. Alfie wants to expand it out, I think. Alfie's comment is a good example here of you've written out your expansion, and because of chat, you've had to write plus ... plus. I might get you to be more precise by what you mean. So I might ask you for more detail if I want more detail. People in chat I've seen of like binomial stuff. Yeah. You know the binomial expansion. And here the binomial expansion would have like 1001 terms in it, so that would be horrible. But people are telling me it's irrational because it's in the form of a plus b root 2. A and b are both massive numbers. And if I push a little bit, you know that b is non-zero because all of the terms in the binomial expansion are positive, and when you add them all together, you're going to get some positive thing in here. We might have this conversation about how we know it's irrational, and we know it's a big number. Okay, I haven't given you a question yet. Here's the question. I would like, I want to know. No, hang on. Let's do it how I usually do it. There's two versions of this question. There's the version that I originally saw, and there's the version I actually do in interviews. So the fact I tell you about this number is that it's really close to a whole number. Oh, a whole number. Which is maybe surprising because it's irrational and it's huge, so how can I possibly know anything about it? JWC in chat wants to try some small powers and look for patterns, which is a good idea, and it's why I paused on the calculator thing, because if you said that, I might let you get a calculator out, or if you don't have a calculator, I do, so I might help work some of them out. We might work together to try some smaller powers. 1000 is definitely a big number. Good, okay. Is it a perfect square? Well, it's irrational, so if we're counting this as a square, then I think we're counting almost everything. Am I going to ask for the greatest integer exceeding that or not exceeding that? Maybe. What I normally show people is sometimes they suggest some great reason for why this is really close to a whole number, and then we go there. But usually I say this, they say, "Wow, I can't see why that's true." I ask them to consider 1 plus root 2, 1 over 1 plus root 2 to the 1000. So, what can you tell me about this number? Which is a really open-ended question again. And my aim of doing open-ended questions is that I want you to say the kind of key things in this little proof that we're going to do. We're going to prove that this thing's really close to a whole number. And the more I get you to say, the better, because I want to see you do this question. I reckon this person, anonymous person at the top of chat, has maybe seen this before or seen something similar. Or recursion relations to try and build things together. That's a nice idea. You discover something. If you do that, I think you find something really good, like, well, you can get some sequence to maybe work out depending on how much you know about recursion relations, you can work out what A and B are in some sense. You can get expressions for A and B in terms of the number 1000. That's not very helpful because then we're going to need to know how big root 2 is. Desmos says this is infinity, right? Yeah, so Desmos has given up. So does its enormous number. This is tiny, and every other term. Cora, I like this a lot. Cora's just disappearing off the bottom of the screen. I almost missed this. Every other term has square root of 2 to the an even power, so it's a rational thing. So this combination, as we expand it with the binomial expansion, and imagining doing that is a really good idea. Imagining expanding it, we would get a series of things with root 2's in or not root 2's in. This is a little bit tricky for me because I'm kind of interviewing everyone all at once. So Eric thinks that this new thing could be written in the form a plus b square root 2. There was a suggestion somewhere down there about rationalising the denominator, I think. Yeah, I think this is a good idea. Okay, I think that this is, so if I multiply top and bottom by, oh gosh, root 2 minus 1? That's d1 minus root 2, I'll look nicer I think. Yeah, something like this. To the power of 1000. Then on the bottom I'll get 1 minus root 2, 1 plus root 2, which is the same thing as 1 minus 2 to the power of 1000, which is, oh I guess that's a minus 1 to the power of 1000 at the bottom, which is the same thing as 1 minus root 2 to the power of 1000. Okay, and usually after we've done this calculation, we probably made some mistakes on the plus and minus signs and the multiplying up and the negative 1 to the power of 1000. We've fixed the mistakes, we've messed around, and there's an idea that we need here. There's an idea about things like this. I'm now looking for the idea about why this is interesting. What's the point of this new thing? What can we do? Well, 1 minus 2 to the 500 doesn't matter, but there we go. Yes, true. No, same thing, but slightly disagree. I mean, there's equal, so split the difference. I've got loads of these brackets and loads of those brackets. I've got loads of both. Yeah, no, I mean that. Good. Adding them together. The thing Cora said is really relevant right now, and several people have put this in chat. Thank you. So I like this idea. With lots of people working together in chat, I think we got there quite quickly. Usually people have been wanting to try other things first or doing other bits and pieces, and I'm picking out of several people in chat to pick up words to do. Oh, geometric series is a really nice idea. Yeah, okay. It's not just rational though, it's a whole number. So at this point we're kind of done, more or less, because we've got the thing we're interested in plus something really small. I know it's really small because you told me it was really small when we wrote it down over here. We've got the thing we're interested in plus something really small, and that's a whole number. And I think that means that this thing is very, very, very close to a whole number. I don't know which whole number it's close to. I can't really tell you what that number is, but I know that it's really close to the whole number. I'm just checking something on a calculator. That question about whether calculators are allowed was very perceptive. Yeah, okay. Good. Okay, do you want me to say that again? Or no? We say that again? Oh yeah, you can solve it as x plus 1 over x. Gosh. Yeah, it's a bit like that, isn't it? It's a bit like x plus 1 over x, where you're using the fact that... sort of. Yeah, cool. Okay. Seems relevant. Why is that a whole number? So if we imagine multiplying it out, don't actually try this at home, but if you imagine multiplying it out with the binomial expansion, then all the root 2 terms cancel. You start off over here, you start expanding this one, and you think, oh gosh, that was enough work for right now, let's go over here. Over here you expand this one, you get a 1, I find 1 plus 1 is 2. Welcome to the Oxford MAT Livestream. But then the next term you'll write down here. You write down 1,000 times root 2 times 1 to the power of 999. Oh my goodness, right, okay, so that's root 2 times 1,000. And over here, the second term I'll get is minus root 2 times 1,000. And those ones cancel. And this minus sign in the powers that you get from the binomial expansion keeps appearing, flipping between plus and minus signs, so that all of the odd numbered terms, all of the odd powers of root 2 cancel out between those two terms. It's really beautiful. All the even powers of root 2 are integers. So you're left with a whole bunch of whole numbers and some powers of root 2. Ben was watching it 2 times. Yeah, we're not going for the a plus b root 2 form, partly because a and b are both huge, massive integers. You could calculate them. That sounds like fun. Sort of want to do that next, actually. But no, I'm going to stick to my interview question plan. So this is quite fun. Just to check that people have understood, I would normally ask at this point, is it just a little bit less than a whole number, or is it just a little bit more than a whole number? Let's use words instead of vague symbols. Less than. You see, this doesn't mean anything either, right? This question is very poorly worded, but hopefully by communicating I can show you what I mean. I mean, everything is less than a whole number and greater than a whole number. This has actually got much worse. Like pi is bigger than a whole number. It's also less than a whole number. It's less than quite a few different whole numbers. It's bigger than just as many whole numbers. Goodness me. Yeah. But everyone in chat. Oh, come on. Everyone in chat's going to do it. We're not doing this poll. There's sort of votes for slightly less and slightly more. Point is, I suppose, that we're adding. Let's see. I think democracy is 1 in chat. I think it's a little bit less because we had to add on this very small amount to get a whole number. So this will be a little bit less. Okay, so this is an example of like the first bit of a question, or maybe the first bit was talking about this bit, second bit was talking about this number, and then having an idea to add them together and talk about that, which I could help people with. I can show them that adding is good. They've still got a chance to have this good idea about what would happen if you multiply them out, and we can start talking about the binomial expansion. We can help along the way. The bit I really enjoy about this question is to come back up to the top and say, what if this number was something else, like 2023? What if I changed that number up there? What can you tell me now? So this is an attempt to get you to speed through. There was not a poll. We could have done a poll, but there was not a poll. This is an attempt to get you to try and speed through and see what happens. So 1,000 was a really big number. 2023, next year, is also a really big number. Can you tell me anything about that number? More is square root 2 is approximately 1.4. Yeah. Square root 2 is 1. Good, I love it. So diving in, this person, anonymous person here, knows roughly how big square root 2 is, so they know that this term here is about negative 0.4, more or less. Okay. Okay. People are saying really exciting things in chat. I was not expecting people to say that. I think it's true. Even closer. So people are doing a comparison, which is nice. People are doing a comparison, which I really like. And there's concern in chat that maybe I don't think the terms will cancel. If you say that out loud, that's brilliant, because then I can sort of discuss it with you. And we can maybe agree after a little bit of chat that actually it's fine, the terms do cancel. The thing is that the ones start off the same, and then it's the next term, root 2 times 2023, that cancels. The last term is different, it cancels, because the last term has an odd number of minus signs in it. So the cancellation is actually still fine. Lots of people in chat have also told me that the thing is oh gosh, have we got a point though? Have I told you a big lie? Maybe I've told you a big lie. Yeah, I do need to change something, don't I? Ooh, help me out, chat. I might have lied to anonymous person. No, I think I'm correct. No, I've decided I'm right. Yep, I've decided I'm correct. So not much changes if you switch all these thousands to 2023. Almost everything is still the same, except, do I need to panic here? I think I need to panic here and say that this thing is actually negative. Maybe that doesn't matter and I shouldn't panic, and I shouldn't use words like panic to describe my minus signs, because there's bigger things in the world to panic about. My plan is to still add these things together, and that is a whole number. That is still a whole number. The cancelling works in the way I wanted it to. But now I need to remember, let's change all of these. I need to remember that this thing inside the brackets is actually negative. Gosh, so this thing to an odd power. I almost tricked myself there. That was terrible. Massive crisis, as if I'd really tricked myself. I shouldn't say massive crisis either. There are other things in life that I could describe as a massive crisis. Gosh, overdoing it a bit. Yeah, it's odd. Yeah. To an odd power, this is now negative. So it's still true that it adds up to a whole number, but now we're adding on a little negative thing. So this is now going to be slightly bigger than a whole number. Wow, I made a mess of that. Chat was way ahead of me. Somehow. Good stuff, chat. So I did quite like this changing your work, or saying, can you follow it through? Turns out I can't. I might get a little bit nervous way too easily. Yeah, that thing is negative. So we're taking this huge number and adding on a negative bit. The alternative would be to say we should subtract. Oh gosh. There's a different way to rationalise the denominator, where you kind of multiply top and bottom by -1, and then you write down something very slightly different. You could write it down as subtracting a positive thing. If you don't like negative things inside your brackets, you could rewrite this as √2 minus 1 and 2 minus 1 on the bottom. And then you don't have to worry about the power downstairs, but you get √2 minus 1 upstairs, so you have to worry about the cancellation a little bit as well. Oh gosh. Yeah, Zoe wants to take it away, and then -1 was minus is a plus, so yeah, that should work out. What do you do if the interviewer is unsure? Usually, the interviewer shouldn't be unsure about their own question. This is an embarrassing and unprofessional state of affairs right now. Sometimes it's because you've said something that they weren't expecting, which doesn't mean it's wrong. It could just be really clever. When everybody said everyone in the chat said it was closer, that scared me a little bit, because I haven't thought about this question for a while and I wasn't sure whether it was closer or not. I think you're correct, by the way, chat. I've caught up. This thing is controlling really how close we are to a whole number, and raising it to a bigger power means we get a smaller thing, so we're going to be closer. I think that's true. This thing, the distance to the nearest integer oscillates positive and negative, and gets smaller in magnitude. I might try and get someone to draw a graph of that one day. Who knows? Panic, calm. You don't have an interview, panic. Oh, Carl Frederick Gauss, you'll be okay. Yeah, people are very worried about this negative. The numerator is also negative. The thing is, I wrote down this minus sign over here. I wrote down this one so that everything would be correct. But then I decided to add on negative of all of that. I'm not actually adding literally the thing I wrote down. So one way to think of this is to put in a minus sign here and here instead, so that this line says consider the number with a minus sign on the top. That's equal to this thing, and hey, this is still small, which is what we needed to do. These ones are small, and these terms are far away. What are we actually trying to do? Yeah, well, I suppose we're trying to write down some sort of statement about how this thing, 1 plus √2 to a big power, is close to a whole number. Cool. Did people spot? I don't normally do. Maybe it was obviously about odd numbers, because why did I write 23 instead of 22? I don't like using the current year very much. using the current year feels a little bit like a bit of a trick. Right, good. What is going on? What is going on? If you'd like to know what's going on, then I'm going to take a suggestion that I saw somewhat earlier on. Your calculator can't work out that number. Here's what's going on. 1 plus root 2 is about 2.4. Right, cool. 1 plus root 2 squared is about 5.83. 1 plus root 2 to the power of 4 is about 33.97. 1 plus root 2 to the power of 6 is about, I've got a calculator right now, right? Incorrect. 197.995. There's something going on here. This interview question is taking that observation and turning it into a question to say, when you've got a really high power, when you've got a really big power, this thing is very, very close to being a whole number. You get a whole load of 9s around here. I first saw this question, I think, on the Maths Cafe problem of the day screen. Good, okay. Hiding stuff behind dummy variable. Good. Right, okay. I've done one of very positive and negative. I didn't think were we worried about this? Okay. Have St John's sent out? You've received an interview from St John's, wondering what the best way to prepare would be. You could take a screenshot now, if you like, for what happened in the first 25 minutes. Good. Okay. Would anybody be able to devise adding on this little bit? I don't know if you've not seen it before. So this question is not really about guessing this. It's about doing some arithmetic and having this idea about adding things. And I haven't shown you the last bit yet, which is, can we change these numbers? And I mean this number and this number. This is a chance for you to do some sort of pattern spotting or to do some adaptation on a bigger scale. We tried changing the number in the power. And hey, there's things either slightly more than a whole number or slightly less than a whole number. What can you tell me anything about big powers of other irrational numbers like this? Goodness me. How did I learn that skill? I'd seen it somewhere else before. I'm not really sure how maths learning works. I've seen a lot of maths things. Good. What calculator am I using? I have a story about the calculator. The calculator is product placement. We got sent a calculator by a calculator company in a shameless bit of advertising. And they're probably very disappointed that I've never shown the calculator on the live stream. Yes, right, because I don't want to have to declare it on YouTube as like a hashtag. Because is it an advert? I think the things, social media rules are really weird now. You have to declare it, even if you're not getting a payment, if you're getting a calculator. Also, they didn't send it to me. They sent it to someone else in the department who didn't want it. So it's not even very effective product placement. I'm trying to make it sound like a sponsorship, so I can talk about trying to make it sound like a sponsorship when really it's just an unwanted calculator. Good, but it reminded me about product placement. Generalise it for A and B. Right, that's very general. A plus square root of B. And there was a suggestion there. 1 take away 2 is minus 1. That did seem really important, and I like that you've said that. This bit was really good. It's 1 take away 2. If we change these numbers around, then maybe we should pick ones that differ by 1, so that we get something like this happening in the algebra. Really like that. Hexadecimal calculators. Not all A plus square root B work. I think that's true. I think you would know about this if it was always the case for 3 plus square root of 7 or something. He says just trying some big powers of this, don't mind me. Oh, these powers are too large. Oh no, okay, right. I don't know what's going on. Goodness me. We've got some sponsors, there we go. For just total clarity, this is a joke. We're not sponsored by NordVPN or Raid Shadow Legends. Goodness knows if advertising standards are going to get on us for joking about being sponsored by things we're not sponsored by. Good. Right, A take away square root B. Oh, you want the mod to be less than 1 so that you get a small number over there. Ooh, that sounds good. That sounds good. Maybe my 3 plus root 7 example is a good example. 1 plus root 3 was suggested, I think, because they were thinking about how 1 take away root 3 is between -1 and 1. Geometric stuff, isn't it? You've got some 2's around here, but I suppose the 2's ultimately still, you can probably fix it. You can probably have an idea to multiply through and talk about things being small. 1 take away square root n. What's this about 1 square root n? This bit really tests me as an interviewer, of course, because people will suggest things and I have to really quickly decide whether I think they're true or not. So I've seen people talk about things like n plus square root n plus 1 to the power of like 1,000 or something. I think stuff follows through, so then you can do some maths. You can make a hypothesis and test it. So that's quite fun. The same sort of effect, that large powers are close to whole numbers. Good. 3 plus root 7 apparently does work, because I picked 2 quite similar numbers. And something about odd and even numbers is probably true in there as well. Sponsored by Oxford Mathematics Institute, and that one is actually true in the sense that this is the Oxford Math Institute building, they're my employer, this is my job. Right, good. Okay. Oh yeah, hypothesis. I mentioned it in a science way though, like we had a science hypothesis and then we went for it. I've been trying to think about maths as a sort of science recently. Don't tell the scientists, they'll laugh at me. You have an idea and you go and test the idea and you can try it out. Ooh. But this is the graph of, there's Desmos. Always like a Desmos. What I want, I think, is like the, it's the, they've taken off the integer part. They've rounded it. I like this, look at this. Thank you for making this. It's a Desmos chart of this thing bouncing around and decaying down to 0, but positive and negative. Ooh, yeah, let's try other ones. Can I do this in your code? I think I can. Hi, just trying out some other stuff. Ooh, so what's that one doing? That one's doing something else. Why does that one take so long to settle down? Not sure I believe all of these Desmos. Right, okay, Desmos, a bit weird. Is that one bigger than 1? No, I'm just not sure I believe that. Right, okay, something's going on there. Maybe a Desmos thing, maybe a powers thing. Breaking Desmos is fun. I'm not quite sure we broke Desmos just now, but hey, we had a go. Consider mod 1. Can you use triangles? Can you use calculators in interviews? Usually no, unless somebody gets a calculator out and says let's use a calculator. I think I might be a bit unusual in that I haven't enforced the calculator ban all the time. That sometimes someone says something like, can we just multiply these numbers? And I'll be like, oh, okay, let's get a calculator and do it. I think don't use a calculator unless ask first. Can I use a calculator to do this? Definitely we're not going to use calculators to like do integrals and stuff. But for that question, I can imagine someone saying, oh, how big is root 2? And we can work it out, but it's about 1.4, right? I wouldn't mind if someone was like, can I check out my calculator? I'd be like, fine. Mathematicians have got calculators too. I've got mine because it was abandoned. It should be 1 over m. Not sure what that one was. Okay, might have broken that. Oh, that voting's quite close. I like it when the voting's quite close. The Hill votes mean that it's not going to be above 50% on the winner now, which is that awkward thing where more than half the viewers would like it to not be happening. Good. Right, okay. Yeah, the triangle parabola question I've done a lot. It's maybe my favourite. It's maybe my favourite question, but I've used it in lots of other things. I get asked to do an interview workshop for maybe a college maths event, or maybe a summer school, or maybe some sort of school visit or something, and I don't have enough different questions to do different questions all the time, especially if I want to give you options and a vote. We're probably going to do all of these, to be honest. I think we're doing them in numerical order at this rate, if the voting goes like this. Good. Oh, people are making conditions. People are doing like... This is why the interviews are 25 minutes, in a way, that you could talk about that question quite a lot, but really I've got to talk about it for about 10 minutes, and then the other person's going to talk about something else. Okay, right. Big triangle, re-rolling and getting votes, and then if we've got time we will also talk about hills briefly. Let's go. Big triangle is maybe my favourite question. I used it for a bit and then I've really milked value out of it since then, by reusing it for everything else as my go-to example of a question. I'm bigging it up maybe too much. So it's the parabola y equals x squared. A, B and C are all points on the parabola. A and C are fixed. B is somewhere in between. I would like to maximize the area of triangle ABC. And I like this because people have got different approaches and different starting points, and I'm not actually sure what the best thing is now that I've seen other ways in. Easier and harder interview questions, asks Eric. Yeah, I think the best interview questions start off a little bit easy and end up far too hard. That's what I'm aiming for, I think. I want the first bit to be a little bit like, yeah, that's a big number, and I want the last bit to be like, oh gosh, n between the square root of n plus 1 and n minus 1, but we're not quite sure if that's bigger or smaller than an integer because the rounding is all different, and we're flowing it through. We've just gone past the halfway point. Remember to stay hydrated. Sorry if somebody said that in chat and I missed it. Yeah. People seen this before? So I've drawn it like a right angled triangle, and that's a good question. If you ask me a question in an interview, I might ask a question back. We can have that as a conversation. I don't know the average computer science math score. Sorry, I think you've asked that a few times. I should have said, I don't know, I'm sorry. Also, it's a computer science statistic, so in a very literal sense, it's not my job. Thanks, Jack. Height and normals. Should we use the mean value theorem? There's a bit of a problem. If you say mean value theorem, I will say, mean value theorem tells you that there's a point with the same tangent. What's that got to do with anything? And there's this sort of, if you say something about really high level complicated math, mean value theorem is something you learn about at university, and it's quite early on. Sometimes people learn about it in advance, especially depending on where you learn stuff at school. If you say something like mean value theorem, we're going to have a quick chat about mean value theorem, and maybe we're going to do the question in a different way afterwards. You could integrate. Yeah, I think if I put B, if I tell you where B is, then finding the area of that triangle feels like it could be a math question. I mean, the area... It's not a very good math question, it's quite boring. You'd have to find... Well, how would you... Anyway, maybe this is a good one. Tell me more about this integration. Always ask questions in an interview, right? Less about me, more about you. Tell me about this integration. The best. B is going to determine the height to maximise the perpendicular distance from B to AC. So I like this because, yeah, there is this way of doing the question. That is also how I would do the question, so I'm always pleased to see it. Yeah, find the maximum perpendicular distance from the base to the point B. And this might not be the middle of that point, middle of that line. this might not be an isosceles triangle, but we would like to maximise that height. I quite like this idea because it's clearly a good idea. You're using a fact about how triangle area works, triangle's base times height over 2. The base is fixed. In fact, we've only got one thing to vary, which is the height. On the other hand, how are you going to do that? How are you going to maximise that perpendicular distance? Where are you going to put B to, in your terms, maximising it? Was there an evil laugh after mentioning Matt? I was evil laugh at realising that this would be a hard and boring Matt question, and I've got to fight that. I've got to fight that within myself. That writing down the area of this triangle given 3 points is really gritty and not fun, and it could be a Matt question, but no, it'd be rubbish. Everyone would hate me. The best did get there. I think there was a chat comment. I didn't read it out. If you've been on the stream before, then sometimes if I don't read out your comment, it's because it was the next 5 minutes of what I was going to say. Yeah. Oh, equations, lines, substitute y. Well, okay. But the best is proposing a lot of work down here. Strong username. Right, good. Find the perpendicular line at AC and set it equal to x squared. Yeah, the problem is we don't know where this point is. We don't know that it's the perpendicular bisector of AC. We know that this line is perpendicular to AC, but we don't know it goes through the midpoint of AC. That's a subtlety that not all triangles are isosceles. This one is really big, might not be isosceles. Parabolas are a little bit funny, I suppose. Yeah, I'm unnamed. There is a shoelace method. I discovered the shoelace method. No, I learned about the shoelace method. I didn't discover the shoelace method. I learnt about the shoelace method when I was marking a step question, and the step question needed you to find the area of a triangle, and lots of people wrote down this symbols that I didn't understand in a shape that I didn't understand, and then equal sign area of the triangle, and eventually I learned that that was the shoelace method for finding the area of a polygon. It's very impressive. We should do it on we should do it on Maths Club. A squared equals b plus or minus 1. Yes, those work. I think so. Yeah, I think that's good. Yes. I think I'm wrong about this n. I think I'm wrong about something I wrote on the board in pink. I think this is not right. I think I want a squared in here. That's not useful to anyone except my own ego, right? Of trying to be correct. You could probably prove that the shoelace method works. I don't really like that. That sounds like effort. Right. Yes. Okay. There we go. Find the tangent to the curve. People have spotted, and I really like this sort of geometry thing, that the tangent at B should be parallel to that line. Well, okay. Said differently, if you draw a parallel line, that shows you how tall this triangle is, what that height is. So that if your triangle was over here somewhere, this point B over here, then this line would be a way to measure the height, the distance between those parallel lines. We want this line to be as far away as possible, so we want to move the point B so that this line's as far away as possible, which is what happens if you make it the tangent. That's the furthest away you can go. Okay, find max a hat minus c hat times x minus 2. Oh, right, okay. But the times in the middle is like the times in the middle is like area. Okay. Can I request that my interviewer doesn't give me geometry? Is this geometry? I think this is geometry. But it's also algebra, because geometry and algebra are pretty similar. Right, okay. Assign dummy variables to them. Yes, and it turns out to be nice. It turns out to be really good. The answer is actually good. Let's do the maths. We haven't done very much maths on this stream, I suppose. Let's go. Okay, so idea. We want to push this parallel line, push B, so that parallel line through B that's showing us the height of this triangle, push it so that line's as far away as possible. If we push it too far, there's no points on the parabola. If that line goes down here somewhere, oh dear, there's no points on the parabola. We can get away with it being just tangent to the parabola. Let's give everything names. Let's say this is at a squared. Let's say that this is at c squared. And then the gradient of AC is c minus a, c squared minus a squared, sorry, over c minus a, which is c plus a. So we want the point B, let's call that b squared. We want the point B such that the gradient there, the gradient of that curve is 2 times x, so 2 times b is equal to c plus a. So that means that b is equal to a plus c over 2. It's the midpoint, it's the average. A plus c over 2, you just add them up and divide by 2. Said differently, that means that b is the, what you get if you take the midpoint of the line AC and you drop a vertical line rather than a perpendicular. Not obvious that you should drop a vertical line, not a perpendicular. I like that being the final answer because people sometimes guess, put b in the middle, and they're right. Can you prove it? How did I decide to use a squared? I know that this point is on the curve y equals x squared, so I gave its x coordinate a name, slow motion replay. Call the x coordinate, I'm going to make this pen a little bit thinner, sorry. Call the x coordinate a, then y equals x squared. So the y coordinate is a squared. This is my slow motion replay of writing down this thing, just giving it a name. I didn't have to use lowercase a, I could have used anything, but lowercase a makes the most sense to me because the point's called capital A. Anyway, 3 trapeziums. I did AC, AB. Ooh. Ooh. And you know where B is? Yeah, okay, so alternative methods. Some people know formulas for writing down the area for a triangle, given the 3 coordinates a squared, b squared, c squared. Write down that formula for an area and then try and differentiate it with respect to b. Maybe they're calling that x and stuff. Maybe they call it x instead of b, so that you differentiate it with respect to x. Write down the area of the triangle. I'm going to try and find these trapeziums. Ben's mentioned some trapeziums, I'm going to try and draw them. Oh, I see. Okay. A, B. Where is this? Could you differentiate? Cora says ignore me, and I had actually missed Cora's message, so now I feel bad. Oh, wait, do a differentiate parabola. Yeah. I found your parabolas, I found your trapeziums, Ben. Yeah, cool. I like it. Write down a whole bunch of trapeziums. Oh, and then differentiate, right? Okay. Hang on. How do your trapeziums work? Let's do this. Let's do some trapeziums. Okay, so the area up here is like the big outside trapezium, which is some of the heights. This is, maybe I should not just do this question again, but getting into it now. Some of the heights times the, no, some of the width times the height over 2. Bit nervous about this. That's the outside one, and then I've also got, I've got to subtract the 2 down here, which is like b squared plus a squared. B minus a over 2, and also subtract the CB, and then differentiate that with respect to B. And say, find out where that's equal to 0. That doesn't look impossible. That looks quite doable. The outside one is fixed, so I can ignore it. These ones, can I differentiate that with respect to B? Probably. Maybe. Right, good. Algebra and partial derivatives, or algebra and do stuff. Right, good. Gauss is off. Oh, see you, Gauss. Right, good. Okay. Yeah, okay. Differentiate. Maybe. Try to avoid multiplying this last thing out. He says multiplying it out, but messily. All of 2. So when you differentiate that, you'll get 3b squared. I don't think I've ever tried doing this before. And then in the other one, you'll get something like rotate the letters. This is the most messy thing. This is not understandable, is it? Abort. Set that all equal to 0, and some of the b's cancel probably. I can't quite see it, but I'm going to take your word for it. Let's move on. Right, good. Ignore a bunch of constant terms. Yeah. Did I not differentiate correctly? Moving on. Right, cool. Other methods exist for finding the areas of this. Very good. Yeah, the at notation's back. Where did that 2b come from? So this 2b, that's the gradient of y equals x squared. And just for a replay once more, the reason was we decided that if you take a line that's parallel to AC, AC is fixed. So if you take a line that's parallel to AC, that shows you the height of the triangle that you're making with a point there. Or equivalently, a point over here, these two intersection points would be triangles that have that same fixed base, and these ones would have the same height. We could do a little bit better though, because we can move the line a little bit, and now they have a slightly better height. They've also moved slightly closer together. But I can do better, I can move the line away even more, and the points have now got more height. They've got more distance away from that fixed line AC. I can keep doing that, and they get further away, they also get closer together, until if I overdo it, oh no, there's no points at all, that's not a triangle. But right in between, there's a sweet spot where I just have the points meet each other. That's the maximum for the area, the maximum for the distance away from the line AC that I can get. At that maximum, there's just one point, one choice of that perfect biggest triangle. We should put B there. Where's that? And then there's this work to say, well, that's the gradient. The tangent works like this. Gradient of y equals x squared. Get some numbers, 2b, because it's like 2x, but plug in the b. Good. Okay. We've seen this idea about moving a line and trying to pick the tangent point when we were trying to maximize. Gosh, there was a question on a previous MAT paper a while ago. There was a circle in there. There was x squared plus y, maybe an a squared plus b squared. Yeah, we were given a squared plus b squared equals 1, and we wanted to maximize something like that. Maximize this. This was equal to c, I remember. And there was like a circle and a line, and you had to. Yeah, this was less than or equal to 1. Yeah, anyway, good. Right, cool. Not interesting. Okay, we're going to do a couple more. I think, how are we doing? We've got half an hour. I think I should do some questions at the end, because I am ignoring a lot of things in chat, or just missing things. You can generalize this to other powers of x. Like the maths is a little bit harder, but not that bad. I think the case with 4 is quite good in some sense. I think I quite like the case with 4. I think there's some difference of 2 squares stuff going on when you change, if you change this 2 to a 4, redo the question. So I like adapting questions and doing the same questions again. Bye, Cora. Right, okay. Okay, here's the plan. I'm going to spend about 10 minutes describing each of these questions. We're going to go a little bit faster, and that leaves us about 10 minutes at the end for questions. Yeah, good. Right. Okay, we're doing them in order as well. So let's do the re-rolling a 20-sided die question. Okay, so you have a fair 20-sided die, or dice or something. The numbers are 1, 2, 3, up to 20. You're going to roll, and then you're going to decide either to re-roll. You can re-roll, decide. You can re-roll to get a new number. Or you can stop and keep your current number. So you roll a die, but then you can choose to re-roll it if you like. I'm nice, I will let you re-roll if you like. And in fact, I will let you keep doing that again and again and again. You can keep re-rolling, and we'll look at your last number before you decide to stop. So you can keep re-rolling as much as you like, and we'll look at your last number, your most recent number, when you finally decide to stop. Except if you roll a 1, then you must stop. The aim is to get a large expected number. And I usually say this out loud. I'm going to write it on the screen anyway. This is sort of statistics, but I'm not really interested in it as a statistics problem so much as a sort of strategy and deciding what you're going to do, game plan situation. So I'm willing to explain what that means or explain how we might evaluate a strategy. I want to focus on people coming up with strategies or coming up with ideas of what to do, so that we can focus on then just finding out whether they work or not, whether they're a good idea. Does that make sense as a game? By the way, without this rule at the bottom, you would just keep re-rolling until you got 20, and that's how you would get a large number, because you would keep re-rolling. It would take you maybe about 20 rolls, but eventually you would get a 20, and you would stop when you saw 20. So then the game's not very interesting because you just keep re-rolling until you see 20. But with the danger of stopping on a 1, it's a little bit risky to keep rolling, because if you roll a 1 at any point, you have to stop, and that's the worst possible outcome. That's a tiny number. Okay. I should try out the whiteboard text feature. Yeah, I didn't realise, when I started writing, I didn't realise I was going to write so much stuff. I regret not using the text feature. Also, my keyboard's really loud. I guess the pen's really loud as well. So, okay. I would say that question topics do vary greatly by tutor to tutor, but not based on personal interests so much. I like Dungeons and Dragons. Sort of what's going on here, I suppose. That's not really interesting advice, right? Okay, so people normally start off by saying this. On average, you have max 20 rolls. Well, you can decide. You have free will. You can decide. Your plan could be to roll exactly once and stop. Maybe that's your plan. That's allowed. You can roll the die once. None of this re-rolling business. Too dangerous. Roll the die once and stop. Thank you. And then we might talk about like the average. So maybe people are more happy if I say average. Average outcome. If your plan is to just roll once and stop, then the average is, I think, 10.5. So that's not very exciting. So I've seen 2 things in chat as well. 3 interesting things. Right, let's try and read chat. Let's try and keep up with chat. Re-rolling on a 2 is a good idea, I think, because life probably gets better. Probably. And we can have a chat at this point, if it's you and me, about why do you want to re-roll on a 2? Sort of acceptable answer. It can't get much worse, right? If you re-roll and you get a 1, well, okay. But if you re-roll and you get something better, there's lots of things that are better than 2, and maybe we'll re-roll and see something better and re-evaluate. Yeah, something about probabilities and expected values. It's a bit like rolling with advantage, which Alfie did a report on during Maths Club about 6 months ago. Was that Alfie? I think that was Alfie. Sounds like decision analysis. It looks a little bit like that. It's not really game theory. It's not really decision maths, I suppose. Some sort of target value. De Best has got a strategy where if you're not running a 1, so this is your chance. Stop when you get a 19 or a 20. So it's quite an ambitious strategy. If you see 19 or 20, then stop. And there's this popular idea that we should stop if we get 10 or more. That's, I think, quite a good strategy. So okay, let's write this down. I'm going to try out the text feature. I've been live 42 times without trying the text feature. I'm going to try it out. I see loads of terrible font. Let's try that. Okay. Re-roll on 2, 3, 4, 5, 6, 7, 8. I think people want to re-roll 9. I think some people want to re-roll 10 as well. Stop on. You have to stop if you see a 1 or 11 or more. Okay. So, tricky question. Can we evaluate this strategy? Can we evaluate what the average is, or what happens if you do this? And that sounds like a very complicated question, involving lots of thinking about re-rolling and probability trees and branching, but there's a way to cut through. Is that a maths degree question? I've only used this a little bit, and now it's dead because it's here. Yeah, I think this is suitable for maths students. Is it a mechanical keyboard? No, I don't know. It's just, it's from work. So why do we have to stop at 11? I don't know. This is a suggestion. This is an idea, I guess. I would like to try and evaluate it though, to work out what the we're just one in the biggest. So look, there's other strategies in chat as well. Let's write down this one. So I can't find the text anymore. Alternative idea is to stop on 1 or 20, nothing else. And what I really want is to decide, well, which of these strategies is better, and then can we think of an even better strategy or not? Yeah, so Raphael said it feels like 2 you should re-roll, 19 you should keep, and maybe something else in between, which disagrees with this second strategy. Once rolled, the history of rolling is gone. Yeah, so Eric's right. Once you choose to re-roll, it doesn't matter what your previous rolls were. You're still in the game. None of the previous results matter. You re-roll the die, and that's the only thing that matters now. The game is all about the last number that we see. So you don't have to do this kind of probability tree of thinking about all the branching routes that you might have taken to eventually rolling a 1. American whose teacher is barely letting them watch, found out how to change the username, would keep 15 and up. So there's different strategies, right? I haven't yet seen, how can we evaluate these? So let's think about, this one is slightly easier to think about. Let's think about this second strategy down here. What happens if this is your strategy? Let's say I get you to play this game like 1,000 times or something, and your plan is to stop on a 1 or 20. That sounds boring. Let's get a robot to do it. So you explain to the robot, you have to stop on a 1, you're also going to stop if you see a 20, and you're going to play the game 1,000 times. Good luck, off you go. Robot rolls a lot of dice. Right, let's read these. Probability you get a bigger number. Yeah, okay. Keep track of weightings for expected values. Oh, very tricky. I want to answer this one, I think. Ooh. Dash has got an estimate for that thing, I think. Raise your guarantee, accept the first roll. So accepting the first roll is, like, I think, on average about 10.5, because there's 20 different things you might see. They're all equally likely. This is dice expected value average sort of calculation. The average is you add those things up and divide by 20. Yeah. Rolling a 1. People are splitting them into groups. Binomial. Oh, probability you will stop on your next roll. You can work out the probability you stop on the next roll. That's quite a tricky calculation in a way, and it's also not quite what we want, because if you don't stop on the next roll, you keep playing, and you will eventually stop. Maybe that's worth saying. You will eventually stop with the probability 1. Yeah, people are now comparing loads of strategies. This has got a bit out of hand because there's now so many. Eric says that A be 1 over 20 plus 20 over 20. Probability that you get a better thing the next time. Put the weights in and guarantee it. Okay, let's say, ooh, Desmos for big triangles. Been distracted by Desmos. There are now 3 things going on in chat, and one of them is complicated. But people are simulating this. I didn't really want people to simulate this, because if you simulate this and break it down a little bit, what you will see is, if you play this 1,000 times, you see about 500 games end with a 1. And about 500 games end with a 20. So the average of those is about 10.5. So this is not actually better than just stopping after the first roll. There are good outcomes rolling a 20 and bad outcomes rolling a 1, and those average out to 10.5. Okay, so we need average outcomes. We can maybe make some sort of self-referential formula. Oh my goodness, I haven't got the brain power to process that self-referential thing. Average outcomes. Oh my goodness, risk factors. How risky a person is. Okay, I think there is a best strategy. So risky people who like large numbers and risk-averse people who also like large numbers will do the same thing, I think. I suppose if you're really risk-averse and you don't like large numbers, then you should just roll once and keep that 10.5. If you're risk-averse and you don't like large numbers, then you do this, I suppose. Anyway, yeah, so the numbers we're going to re-roll on don't really matter because we're going to re-roll. And eventually we'll stop on one of our stopping numbers. So I think these people telling me about average outcomes are telling me the way to evaluate these, finding the average of the stop set. Look at the set of numbers that you'll stop on and find the average. So the question then is, this one has average 10.5, this one has average, who knows what the average of this is, right? We're going to have to work it out. Add up the numbers from 11 to 20, add on the 1, divide by 21-ish, no, divide by 11. Yeah, always stop on the stopping numbers. Right, good, okay. So add them up, evaluate those by finding the average. If that doesn't make any sense to you, then that's because I'm trying to go quickly. I'm not sure I'm going at the right speed for anybody because there's too many people here in an interview. Make sure that I understand it and you understand it, and then we can talk about maximising that average by changing this number. I think the best answer turns out to be to re-roll almost always, unless you roll a 1 because you have to stop, or a particularly big number like a 15, 16, 17, 18, 19, 20. I think that's the answer. Homework question, do you want to re-roll your 15s or not? Let's talk about hills really quickly. The hill question works like this. Oh, it must have been a reference to the joke from before because I didn't tell you the function. You have a hill that gets steeper and steeper, y equals e to the minus x, and a particle that's moving down that hill, it starts at x equals 0, y equals minus 1, velocity 0, no velocity to start off with, and then because it's got some slope, it starts moving, moves so that I suppose kinetic energy plus gravitational potential energy is conserved. So no air resistance, no other stuff going on, no friction, no rolling. Keep it just sliding down the hill. And the question is, how fast is it going when it's at x bigger than 0? Some point later on, as it's rolling down the hill. So that's sort of fairly standard mechanics question, I think. You can do some components of velocity vectors. You can write down the relationship between speed and velocity vector. You can square things and add them. I like doing a mechanics question sometimes, not all the time, but sometimes I do something that's a bit like mechanics because actually this is algebra and differentiation and Pythagoras and vectors, and all the mechanics that you need I can tell you. I can tell you what kinetic energy is. I can tell you what gravitational potential energy is, and I can tell you that adding these things together, oh not Z, I want Y for this one, don't I? I can tell you what conservation of energy means. Usually people have heard of conservation of energy, and in a pinch can write down conservation of energy. What I want to do with this question, which I've actually never done, is to talk about acceleration instead. There's some interesting acceleration going on. And really what I want to talk about is normal forces, but I've never done that Bickett's normally people not as exciting about this. Yeah, so Nicholas, is the ball always in contact with the hill? It's a good question. It's where I want to go with this. To start off with, let's assume that it is. And in fact, every time we've done this question, we've done some vectors and Pythagoras and squaring and writing down energy conservation and done the mechanics question, and never really talked about contact with the hill. So I've got the least to say about this one, I think, because I only used it a tiny bit. I've now burnt it by putting it on a live stream, but there's some interesting stuff going on. I've seen questions in other places about things rolling off spheres. They kind of lose contact at some point, or a hoop that turns over and has a particle stuck to a hoop that rotates and at some point loses contact with the ground. Good, okay. The answer turned out to be 16. Stopping with 16 or more, or 1. Pretty steep hill, probably a cliff. Yeah, maybe I should call the question cliff. Yeah, okay, good. Yes, okay, Eric, nice. Yeah, free fall would be a parabola, but this thing goes faster than a parabola. I think that's a good rule of thumb. I think it's true. I'm a bit worried. This is the thing about building. If you build a ski jump slope that gets steeper and steeper and just goes too fast, then you've actually not built the ski jump bit. You've built the aerial bit of the ski jump, and the ski jumper will ignore the thing that you built and do the jumping instead of the skiing. And there is some maths you can do to work out whether a particular hill is for skiing or for jumping that we can work out. What exactly is the question asking for? An expression or a value? I would quite like an expression in terms of x. So that later on I could say, aha, now it is at x equals 3, what's the velocity? But I don't really care about x equals 3, I care about later on x. There's this relationship, right, between where it is, the height from x, you can work out y. If it's on the hill, x, you can work out y. You know how much energy it's gained, you can work out its velocity, it's going tangent to the hill, so you know the direction, you know the magnitude and the direction of that vector, so we can write down some vector nonsense. We'll have to differentiate some exponentials along the way. I'd be lying if I said that I love this question, or indeed that anybody I've ever shown it to loves this question. Good stuff. Right, oh yeah, look, there's some gravity. Yeah, ski jumping as an analogy. The gradient's good because it's also, yeah. Somebody appreciates the fact that I picked e to the x. Yeah, I could have picked loads of functions, but I picked one that we can differentiate and stays nice when you differentiate it. There is some things you have to consider when you're coming up with a good question. I'm not sure that is a good question because everybody hates it. What kind of questions do you get asked? Good, right, that was been the interview workshop live stream. What's this called? Yeah, Eric. Eric wants to talk about contact. It's yeah, after it loses contact, it goes into a parabola and it doesn't regain contact. You can do what I really want to do. The question I'm not going to do is there's a classic kind of loop-the-loop question where you have a kind of loop-the-loop. I've seen this in so many different places. You want a little Hot Wheels car to do a loop-the-loop, so you need to start it quite high so that it does the loop-the-loop and gets all the way around. And there's kind of this question of if it doesn't make it, what shape? So it goes up and then at some point it does a parabola and then the parabola will hit the circle. So anyway, it's a question that's not actually very interesting, but is just about doable. Anyway, can we interview me now? Yeah, all right. Do you want to stick an interview question in chat and we'll see what happens? Oh goodness, loads of text just appeared in chat. I'm not scared though. Could you repeat that? One interview, first college college. I think that sounds fine. You'll almost certainly get an interview with a second college if you're interviewed by Oxford. Assuming you're Oxford, in that you've been watching an Oxford live stream for 2 hours. Right, okay. Haven't learned about mechanics. People are scared about mechanics. There's not very much mechanics in there. I know IB, we have your UCAS application, we know if you're doing IB stuff. My personal preference is to explain things in an interview. rather than avoiding questions. But I think both options are available to me. Re-rolling 15 or below. Whoa, Raphael's done 1 million simulations. Did that on work experience make a marble run? Oh, with the loop. Oh, brilliant. I'm glad that's got a practical application. Interviews of 40. Does that mean my math score? It doesn't mean anything about your math score. It means about the people scheduling the interviews have got enough scheduling things to worry about without also making it a function of math scores. Doesn't mean anything. It's just how that college is scheduling things. It doesn't even mean that the interview will last for an entire 40 minutes. You'll be fine. Oh, you want me to integrate x to the x? I don't think it's got a closed form nice thing. Right? I don't think it's got a nice closed form answer, right? Do you want me to do it numerically? I don't want to do it numerically, but the trapezium rule. You like maths, name every number. Do you know the great thing about that question? That question's brilliant. That's a YouTube. You can't name all the irrational numbers. Not for the naive reason is because there's infinitely many, but there's uncountably many, which means you can't give them all names. We play this game like giving things names like pi and square root of 2, and we get emotionally attached to some of the ones we've given names to, like tau and -1. But we're giving names to irrational numbers is a fruitless job because there's way too many irrational numbers. This is a great thing. Yeah. Sorry. Inverse Ackermann function. I don't know what that means. Oh no, I vaguely know about Ackermann functions. I don't know what that means. Identity I have online these use. Please read any instructions that the college has sent you. If the college has asked you to bring ID, then please bring some ID. If you don't have any ID to prove that you are who applied to Oxford, then reply to their email asking for ID to explain, and that'll be fine, probably. Prisoner's already answered a thing. There's no worries, but I didn't see what it was. Okay, just popped in at the end. Didn't get any email. Hear back from Harvard in 2 weeks. Ooh, America. Haven't heard from Magdalene. Sorry. Yeah, I heard someone else from Magdalene's here as well. First digit, the first, second that said, yeah, there's too many irrational numbers. That's Jack's trying to do Cantor's diagonal argument in chat. There are too many things. The other joke is that there are too many integer sequences to give each integer sequence a number. There's this project online called the Online Encyclopedia of Integer Sequences, which is unfortunately doomed by this fact that there are too many integer sequences to give numbers to, even if you use all of the numbers. Chat says they're waiting for cats and waiting from Harvard, so this is pretty exciting. Oh, it's the American. Okay. People are excited about OEIS, and then you learn about countability. And it's a joke because OES is not actually trying to number all of the integer sequences. They're only numbering the interesting ones. And because there are uncountably many integer sequences, it's totally possible that some of them are uninteresting. If there were only countably many, then it would not be the case. They would all be interesting if there were countably many, but they are because they're, yeah. I don't think you're the only American. I think most of the Americans watch on catch-up. Sorry for people who are still waiting to hear back from Oxford colleges. Sorry on behalf of my colleagues doing mail mergers in different orders and different speeds. Will I be asked a lot about my personal statement? I think I have never asked anybody about their personal statement. Some of my colleagues might do it to try and calm people down, or to try and say, so you like complex numbers. What do you like about complex numbers? I mean, you can say something about complex numbers if you like, but yeah. I said some things and I'm stressing about how I can defend them, lol. Yeah, we've all put things in our personal statements that aren't entirely true, and in a very, very literal sense of the word true. And luckily, if you're applying for maths, you're more likely to be asked a maths question than you are to be asked about your personal statement. Right, good. Should I contact my college office? I mean, maybe. It's not going to make them faster. If we all email them, that's not going to make them faster at sending out emails, because now they've got to do twice as many. So I'm not encouraging this overall, but email's free, I think. So email's free, so go for it. Good. Okay. I think we found a second American. You can tell because they say yo with capital letters. Good, okay. Denim wants to know who their interviewers are. I think they tell you in advance. If not, then you might find out. Good. Okay, last person waiting. All going around. Are you going to email? Oh, was it just to confirm? What was that? Was it Eric? Just to confirm. I think let's wait. Let's give them until Monday or maybe even Tuesday. Let's not panic. I'm trying not to encourage thousands of people to email my colleagues. I'm being a good colleague, everyone. 1,000 people want to email you about your mail merge. Right, Eric's watching in Australia. Good. A third American. Right, okay, it's getting out of hand. Now there are 3 of them. Good, right, okay, we're wrapping up now because it's 7 o'clock. Thanks for watching. We wouldn't do this if nobody watched it, and that would be a bit sad. But luckily, at least one person is out there watching this, and that makes it worth doing. It's all about you. Whoever you are, there's one person watching it. Next year, maybe we'll aim for 2 instead. It's been really good fun showing you maths problems. Obviously, been ups and downs through the last few weeks of doing maths problems together. But I really do enjoy seeing what you have to say about maths problems that are happening over here. Couldn't do it without you, and we also couldn't do it without our sponsors this week. No, we don't have sponsors this week. We couldn't do it without support from Oxford colleagues behind the scenes who make sure this thing actually happens and I turn up at the right time in the right place. I'd like to thank Stephen Siklos at the end of all of these. Stephen Siklos got me interested in doing this sort of thing. And also shout out to Zoe, who has actually helped organise everything. There is no stream next week, but we are starting a new season of the Oxford Online Maths Club in January. I get a few weeks off for interviews, admissions, Christmas, New Year, and then in January we start the Oxford Online Maths Club, where we get current Oxford students on, sometimes just me, sometimes Oxford students or staff, to talk about some maths that they're interested in, not to do with the maths, just maths. Last piece of advice, because there's a request there. I wish that I had practiced basic maths more. I think that would have made things better. I said this like a couple of hours ago as well, but this is also going to be my last piece of advice. If you can practice anything, practice the stuff that you think you should be quick at, the stuff that you should be comfortable with, the stuff that makes you relax when you see, it's just a quadratic equation, I can solve those. So my last piece of advice is, I think, get fluent with the fundamentals. Right, good. Okay, people are still reacting to the sponsor news. Oxford rejects Let's All Go Cambridge for postgrad. Part 3, right? You could do Masters, Part 3 over there, or I guess Part 3 MAST, or you could come here and do Part C, doing Oxford Masters Mathematical Sciences, OMS, OMMS. So if you want to apply for graduate study later on, that is now sounding like an advert, isn't it? So there we go. Good. Right, okay. Remember, you're great at maths. You can do this. It's maths. You love maths. You can do this. You've got it. And there was a request for outro music, which I've not prepared. Thanks to Prisma, of course. I forgot Prisma in the thank yous. Thank you, Prisma, for moderating chat, not just this time, but for a whole load of times recently, keeping everything running smoothly. And now I'm actually going to shut up and let you do some maths. Bye, chat. We tried outro music one time. The outro music was in Desmos. It was a bit weird. The Oxford MAT Livestream is not sponsored by Cambridge, Eric. We'll be back Thursday the 5th of January 2023 for the Oxford Online Maths Club. See you there.